We've assembled a panel of experts for you this afternoon to talk about different aspects of real-world LoRa deployments. We have Mike Kidd, who's the Director of Sales for APAC CALA at MultiTech. MultiTech has been offering technologies for machine-to-machine communication since 1970. Patrick Phillips is the founder and Chief Creation Officer at Herelab. Herelab is a design-build LoRa studio that works with communities and companies to design, build, and manufacture LoRa-enabled sensor nodes, primarily for agricultural and architectural uses. Yodit Stanton is founder and CEO of OpenSensors, who has been connecting IoT devices for the last 3 years, and in the last year has been using LoRa on customer production networks. My name is SKMurphy, and I'll be acting as the voice of the audience. Please use the Q&A tab to type your questions for the panel, and I will stir them into the conversation when I see an opening. Mike, I believe you're up first.
Yes, thanks, Sean, for that introduction. Hi, this is Mike Kidd with MultiTech Systems. As Sean mentioned, we've been in business since 1970. We're a USA-based manufacturer. We've been involved in M2M and connecting machines since 1970. We've been involved in LoRaWAN compliant products for the last 3 years or so. We're a USA-based manufacturer, and we make LoRaWAN compliant products. So I'm going to kind of jump right in and just talk a little bit about LoRa, the assumption being that all of you know something about LoRa and maybe some of its benefits. So we'll talk a little bit here just about the technology and some of the benefits. So LoRa, long range, low power, wide area networking, it's very unique in that it gives 13 to 15 kilometer range, and in dense urban areas 1 to 3 kilometers, 5 kilometers dense urban. So it's a great technology. It's not designed to replace FSK or Wi-Fi or Bluetooth or anything. It's a complementary protocol, and it's really good for connecting sensors. It's not good for sending video or things with high data rate, but it's good for connecting sensors. So it's complementary in that, you can see the diagram here, the range, and it's very inexpensive and easy to deploy and very flexible. Why don't we go to the next slide, Sean? Okay, here we've got a little overview of comparing some of the different technologies, and as I'd mentioned, the Bluetooth and the Wi-Fi, and then the other well-used connectivity option is cellular. And again, LoRaWAN isn't necessarily designed to replace cellular in all instances, but in a lot of them it is. So with cellular, you've got very good coverage, but you don't have good battery life, and you don't have a low cost. So the advantage of using LoRa over cellular in the applications that LoRa fits is that you get that long range, you get very long battery life, you've got low cost, most of the time no reoccurring cost, no monthly cell plan, but it's not good for high data rates, as I mentioned. So this slide here just kind of details out some of the good and the bad, the best and the worst of each of the different technologies. Why don't we go to the next slide, Sean? So as I said, MultiTech, we've been involved with LoRaWAN products, manufacturing LoRaWAN products for 3 years or so now. MultiTech's a member of the LoRa Alliance. And the LoRa Alliance is set up as kind of an overview or a standardization body. And so one of the nice things about LoRaWAN compliance is that all of the products and applications, everything interoperates together. It's not proprietary like some of the sub-gigahertz protocols and sub-gigahertz ISM band communication's been around for a long time, but in the past you didn't have a standard, so everything was kind of an island. If you went with this manufacturer A, you were stuck with that manufacturer A. With LoRaWAN and the LoRa Alliance, it's an open standard. Everybody's making things that interoperate together. And that's what makes it such just a great technology. So MultiTech, we've been involved with the LoRa Alliance. We're one of the founding members, and we're active across all the different working groups, planning out the strategy of the technology, certification, marketing. So we've been involved since the beginning.
Mike?
Yeah.
We had a question from the audience, Peter Michael.
Yeah.
What is the maximum number of nodes which can connect to a single base station, e.g. every sensor sending data once per hour?
Okay, why don't we go to the next slide and let's talk about that.
All right. Oh, here we go. Perfect.
Okay, so here's just a slide about the typical LoRaWAN architecture, the overview, kind of the various bits and pieces in the puzzle, shall we say. In MultiTech, we manufacture the N node, intelligent M. and X. devices, and concentrator gateway LoRaWAN gateways. Because LoRaWAN is very flexible, you can configure it different ways. So the basic rule of thumb is that the higher the bandwidth, the more data that you want to send, the shorter the distance that it's going to send. So if you cut it down, the spreading factor, and set it up so that it's sending small packets, it will send a further distance. So the question was, how many N nodes can connect to a concentrator or gateway? There's not just a hard, fast, set rule. In theory, 8-channel gateway with a basic spreading factor at 125 kilohertz, you should be able to, with data being sent once a day and a very low data rate, maybe 50 bytes or so, you should be able to connect several thousand N nodes to a single gateway. That doesn't give you any redundancy, however. So you've got a single point of failure. So most people don't necessarily like to do that. But anywhere from say 1,000 to 2,000 is probably a good realistic view. There is some formulas that we can provide where you can actually figure it out and determine exactly how many nodes can connect to a gateway. The other decisive factor is going to be location. Where is that gateway located in relation to the nodes? If it's in a building with dense walls and lots of steel and concrete, it's going to be less than if it's out in, say, an agricultural application where you've got a tower at an 80-foot height, and lots of nodes spread out. So there's not just a hard, fast, set rule, but it's definitely somewhere in the 1,000 to 2,000 range. Hopefully that answers the question.
Yeah, there was a second part to the question, which was, can this number be increased by adding additional LoRa base stations?
Absolutely, and that's the nice thing about LoRaWAN. So maybe you've got a hole in your coverage, or maybe you just want to increase the efficiency of the network. You can easily add gateways into the network. And so, as I had said, MultiTech, we manufacture intelligent end nodes, and we manufacture concentrators or gateways. The MultiTech products are very easy to use and easy to configure and very flexible. So they're basically an open platform, an open Linux platform. You can actually run your application directly on the platform. And our M dots and X dots, the nodes, those are also intelligent, which means they've got their own processor on them. So what you can do is you can run the application directly on the hardware, bringing that processing power out to the edge and only sending the data that you need to get to the network. That's also going to increase the number of nodes that you can connect, because you're not sending all of the data up. So the more you can keep at the edge, the more efficient it is, and the more you're going to be able to get out of a single network. The MultiTech concentrators and gateways, like I said, they're very flexible. They're open platforms, so they can be configured as packet forwarders. They can run LoRa server directly on the gateway. And you can easily create private networks, be part of a public network, or you can easily create a private public network. So that's one of the nice things about the MultiTech hardware. Kind of drifting off here, sorry about that.
Mike, I just wanted to ask the other two panelists as well. Yodit, does OpenSensors have design guidelines they follow for the number of nodes per gateway?
Yes. So for us, a lot of the time we're doing in-building deployment. So there's two ways that we think about it: is how many nodes per gateway, and also what is the coverage. So to figure out how many nodes per gateway, as Mike mentioned, you're kind of calculating the data rates and so forth, and the sampling rates of the nodes and how much data they're sending over the wire, as it were. The other thing is obviously kind of this distance. The easiest way to test distance, and the way we think about it, is we encourage engineers to set up the gateways, and MultiTech also do the handheld range scanning devices. So you can go around and ensure that you've got sufficient kind of coverage within your area before you actually start installing the sensors or ordering the sensors. So there's a very kind of easy way of figuring out in terms of the data rates via spreadsheet, and also kind of just using a little bit of site assessment to go around and just check, do I have enough gateways within this distance?
And this is Patrick. I just think that it's also important to mention that you also, in Europe and other places, you have a duty cycle requirement. You can only join a certain amount of time per minute. In the United States, you don't have that, but you have a frequency restriction. So you just have to be aware of how much you have to send, how much you can send, and how frequently you should send. That's an important consideration when you're designing and defining both the protocol as well as the network architecture.
So there was a follow-up question, which is, how does adding multiple gateways to the same coverage area increase the number of nodes in the coverage area?
Well, it works very similar to the cellular network. So the node is going to reach out to the gateways, and the gateway with the best signal strength, or the best, the best signal strength that's able to connect to that node will handle all the traffic. And so it's kind of intelligent. And if they're moving nodes, if the nodes are mobile and moving around, it's going to pass off and hand off. So it's very similar to cellular in the way that it jumps around and it finds the best path, which is going to create talk at the highest spreading factor and be able to send the most data.
Yeah, to add to that, I think that configuration and provisioning are also important considerations when you're trying to get nodes onto a network. So a gateway, in terms of authorization, recognizes a particular EUI, and there's a kind of use your pass built into the firmware to enable that handshake to occur. So the joined factor in the firmware will require that EUI to be recognized. So there's a kind of a design framework for how you're authorizing different nodes onto your network will have to be taken into consideration as you're defining your network parameters.
We had two questions that are essentially a variation on the same question, which is, how reliable is the transport between the endpoint and the gateway? If for some reason the endpoint can't reach the gateway, is there a way that it can retransmit or attempt to connect? Yes,
it does exactly that. It retransmits and connects. So that's built into the LoRaWAN protocol, and it's a spread spectrum protocol. So the way it's designed is that it's sending it out. It's very broad, and it's sending out all the bits and pieces, and all of them don't have to get through. Only a portion of them need to get through for the data packet to be realized. But you're basically putting the information into packets, sending packets. There's a start and a stop and a redundancy check. And so if the whole packet doesn't get through, it does retransmit.
So, Mike, you want to share a couple of early LoRa deployments?
Sure. One of the real exciting ones that I've been working with since the beginning is the Things Network. And it was launched as a global public LoRaWAN network. A bunch of guys got together in Amsterdam and said, hey, let's launch a public LoRaWAN network. Within about 6 months, they put up 16 gateways on the top of the tallest buildings in Amsterdam and launched a LoRaWAN network. From there, it's grown globally, and I don't know, they've got 500 cities and thousands of gateways in, I don't know, 100 different countries. And so that's really neat the way that can happen. And the reason that can happen is because the LoRaWAN product or protocol, the gateways and the nodes are so easy to deploy and very cost effective. You know, you can get a gateway and put it up on a building, an outdoor, fully blown IP67 gateway with a cellular backhaul. It's less than $2,000, somewhere around $1,500 bucks, all inclusive. So that's been a real exciting one. Did you want me to speed up here, Sean? Is that why you flipped or the slide? Sean?
Sorry, Mike, I was muted. Patrick, could you talk about Herelab's role in the LoRa ecosystem?
Sure. Hello, everyone. And thank you, Sean. And thank you, Yodit and OpenSensors for inviting Herelab to share our work. It's great to share this stage after sharing the environment and manufacturing and data stage with you for the last 14 months. In my segment, I'll share a bit about how we work and in an effort to help others think about and manage and scale your own initiatives. I think we started as a community initiative. We're dedicated to enabling people within a community to solve problems. And from our perspective, it's important to start where you are and with whom and what you know, and to work out from there. We started with schools and towns and organizations. They are in a community, the need to know and need to share environments. They have to share knowledge or share impact with each other, whether it's a municipal need basis on public data for water quality, or whether it's students in STEM education trying to understand how to use new tools to learn how to manage their environments. And we've taught and engaged municipal organizations and schools and nonprofits. We brought those three kind of institutions within communities together to create these synergies so that each of their needs would actualize in different ways around LoRa-enabled devices and networks. We brought these tools into schools and then brought them out into farms and into various other environments. We then moved out to from a kind of a DIY model to a do it with others everywhere model. So we're no longer just focused on an island and the aquifers or aquatic environments or farming environments here, but began to kind of work with others to solve problems elsewhere. And if you go to the next slide, Sean, so we're a social enterprise design build partner. We focus only really on this base layer of what we call the IoT stack. We design and build. And community and company focused initiatives require partnerships. And so as we began to grow out of this DIY model, we recognize that partnerships aren't informal, they have to be formal. They have to be structured. Because if you can't structure your relationships as a design build studio, you can't scale your business, you can't meet customer needs, or you can't roll out nodes and networks. And as someone is trying to solve, a firm that's trying to solve real problems to design build, we're more interested in a kind of a, not to get too businessy about this, but a B2B relationship. our customers aren't so much the end users, although we will work with schools and we will work with farms. Our customers are more geared toward those people who serve those people. For example, on the community side, and I'll speak to this in a minute, we're working with a small city in Minnesota to do some cultural applications that will build out to enterprise and educational relationships. And we're working directly with MultiTech, kind of a base level to establish those networks. So we'll design our hardware, we'll design the network, and MultiTech will actually help us build out this network in Minnesota to serve that community, and we'll connect those nodes directly to OpenSensors. And so our partnership up the chain from design build to data services is important. And then as OpenSensors makes their data available to others, whether they're architectural firms or commercial real estate, those system integrators need to be able to get that information in a reliable and focused way so that they can do stuff with it. So I think
so Patrick, question on when you talk about the Minnesota build out, what's the demarc between Herelab and MultiTech?
We are building, well, I'll get to this a little bit into maybe we can actually shift to this node unless in the next slide, unless this is important to stay here.
Well, we did have a second question on this slide, which was when you talk about OpenSensors providing the data, Yodit, how do they do that?
So the way OpenSensors works is we have very much a separation between what's known as open data, which is environmental data, kind of pollution data, water quality data, and so forth. That data is accessible if the publishers choose so for anyone. And a lot of what we do in terms of the architectural firms, for example, the in-building data is private data. So inside the building, the data is private, but a lot of our customers, what they're actually starting to do is putting together the private data and layering a lot of the open data, both the real-time data on OpenSensors and other data, kind of environmental, available elsewhere. So very kind of clear separation is environmental data is public data is kind of anyone can access.
So we had a follow-up question. You've talked about using the MDOT units. Can you run user code on those units, or are they strictly radio protocol handling modules?
Well, this is probably important to shift to the next slide. Then it'll share you some information, at least visually. You get a visual cue. Yeah, I think that what we've done is instead of focusing on an Arduino-based MCU platform, we're just using the MCU, the processor, on the dot. So we will put everything, we're working in an embed environment to code, to understand what the sensor is doing with voltage. We'll translate that voltage into a specific configuration set, packet size, so forth, to design out. But we're only using, and intentionally so, using the processor currently on the MDOT, and then we'll move it out to, our next generation will be focused on XDOT. It's a smaller platform, lower cost, and we can do a little bit more with it. The important thing for our framework, and kind of going back to what you say, the MultiTech demarc is, we have enabled our hardware development around community use and applied use cases, and we've centered on what the MDOT can do relative to processing speed and power, how it's working with flash and not. So we're using very closely using that architecture on the chip level to define how we're managing our data usage, or the data kind of pathway, so to speak. But then what's great about MultiTech is that they'll send an engineer down to Winona and work in a kind of a hand-to-hand way to help the organizations and municipal entities to deploy networks. So they're MultiTech. We chose MultiTech after a series of conversations and explorations with others, primarily because they were personable and they knew what they were doing and we could trust their products. So that's not so much a demark, but it's like the relationship. Could go into the depth of that way that we build this architecture out a little bit, but just very high level. We have an I2C bus on it, so you can screw stuff into it. Voltage regulation, there's an Arduino footprint, so you can add shields to it if you want to. We use those shields in the right-hand slide as an aquaponics environment. Of kind of, there's a dissolved oxygen probe and a temp probe built into that. That's using one of our partners is White Box Labs, and a core partner, and it's a little bit remiss of me that we've not brought them up till this moment, is Thing Innovations. They are a really excellent and capable engineering studio that flew out here. We decided what we wanted to do with the local environment. We built our platform based around uses, using their excellent kind of engineering skills. So,
so Mike, we heard from Patrick on his perspective on the DMARC. Could you talk about how you support design labs like Herelab and these build outs?
Sure. As Patrick mentioned, the relationship is probably first and foremost. If you're not going to be able to support the hardware, people aren't going to buy it. So we pride ourselves in getting involved in providing the support, access to our engineers and things like that. And as the question from Victor about can you run code on the MDOT, yes, they are intelligent. So the MultiTech platform, both the gateway and the dots, are intelligent. They have their own onboard processor, their own onboard user memory, and they also use mbed. Okay, so you can go out, you can find the sensors and go out to the mbed libraries and things. And so putting all that together and putting the pieces into Thing Innovation's hands and Patrick's hands and the rest of the team at Herelabs, that's what we do at MultiTech. And then we work with, all the ecosystem partners. So that's kind of what we do. That's why we've been around since 1970.
Well, I see you've shifted to the next slide. My one thing that to speak to is that our goal is to try to make this stuff really easy to use. Our modular design hardware is to enable people to go from an idea to a proof of concept in a week. And then our goal for our next iteration of our hardware is to enable people to unbox and deploy in as little as 5 minutes. So we're working with OpenSensors to create a deployment framework. We're working with other organizations and foundations to begin to kind of create what is the open standard for that as we roll stuff out. I think in this case, in this slide, in terms of hardware and field use design and benefit design, there are 3 things to consider and be meaningful. We took our nodes and deployed a network in an aqua farm. An aqua farmer happened to be a marine biologist and who was interested in chlorophyll and nitrogen. When he could see the data that we were pumping through to OpenSensors on his phone that said that it was safe to put shellfish seed stock into the water at 50 degrees, he could make that decision. He was washing it for 3 weeks prior. He went out and bought 1 million seed stock. That's meaningful, real work stuff that we were very proud to help him with. And in terms of the farm applications, we deployed sensors in a 30,000 square foot greenhouse. And the response to the work was now they check the dashboard every day, and now they don't have to worry about fungus on specific lettuce. They know the humidity and temperature is going to keep it safe, and they can actually go bag lettuce. So that kind of real work, be meaningful work is very important. And then the design to purpose is a really important facet of our experience. If we're doing work with schools and we want to bring that technology into a commercial application, we'll refine that technology down. In this case, we actually have decided to work with other customers to develop a desk sensor, and going back to our partnership relationship. We're working directly with OpenSensors to satisfy certain commercial real estate opportunities relative to passive infrared desk sensor that will do some important work for commercial real estate and managed service providers. So I think the core takeaway there is listen to your customers and do stuff that's sensible and meaningful. The core of our work right now is to move to scaled networks for companies and communities. We're taking what we learned on island applications, and we're moving out to, as we mentioned, to small cities and to large farms. And so if we can begin to have real value at scale, we can respond to and meet customers' needs on a real-time basis as they come to us. So an example of that, and going to go back to Winona, Minnesota, we're designing right now our ARC node to go into a cultural center to facilitate the build out of sensing capacity for Winona State and for enterprise and municipal development. And we'll go there and lead workshops to facilitate that rollout. It's exciting work. I think the kind of takeaway for us is that you could begin to think about these things as really big picture stuff, but to do the first things first. The real challenge is who on the ground will naturally be activated by the technical data and social benefits. And once you've identified those people, you begin there. To hand off to Yodit.
Yeah, Yodit.
Thanks, Patrick. Thanks, Sean. So just as a bit of background, OpenSensors has been working with IoT over the last 3 years. The reason we organized this hopefully very interesting webcast is actually because over the last year, we're seeing kind of wide-scale adoption of LoRa, where previously kind of the majority of people and customers were using kind of either short-range RF or Wi-Fi based sensors. Now we see a big transition towards LoRa, and there's a number of reasons for this. Firstly, it's because you kind of get the nodes, the gateways ready, configured, and deployable within the sites. So the kind of I suppose if you think of it previously, we had nodes that had to be configured onto corporate IT networks, and that was real kind of pain. And corporate IT would push back against these new sensors coming onto their infrastructure. With LoRa, one of the nicer things, obviously, the distance and the coverage and all this stuff is obviously brilliant, but it makes the deployment really easy. And when you think about sensor deployments, actually it's the human cost of deploying these sensors, maintaining them, that's much more expensive than the sensors themselves. So if you can go to the next slide, Sean. I just wanted to give you a bit of background of how we think through larger scale rollouts. Just a practical and simple example would be office buildings. So let's say that you have 5,000 sensors that you need to deploy within real estate. How do you go about it? And a lot of the time, these basic sensors are, kind of people are thinking about motion, temperature, air quality, the noise, and for our customers, especially people like architectural firms, building managers, they're thinking about how do we make these spaces better utilized and also nicer places to work in. So practically, the first thing is figuring out the gateway to node ratio. I touched on this earlier, but you're kind of thinking through what is the data packets that is going to be sent over the wire, what is the range. So kind of figuring out how many data packets and how many nodes. I like to be quite conservative. So even if I work out that we can have kind of 1,000, 1,500 nodes to a gateway, I kind of go for the conservative estimates of 500 to 800. Generally, you can have enough redundancy built in there that the gateways aren't the single point of failure. The other thing that you need to think about is, okay, once you have the data, what happens next? And really what most of our customers want is to get integration with existing applications. WebCore is one of the largest kind of facilities management CAFM systems. We provide integrations with that, and also build and design tools that architects use. And then we provide our own kind of visualization tools like heat maps and so forth. But a lot of the time, actually, the most interesting thing happens when you start providing these data sets within applications that people use already.
We got we had a question on the bandwidth. You've talked about pulling data off of the end nodes. Is there enough bandwidth to be able to do firmware updates to the endpoints to the end sensors?
No, there is not. I wasn't sure if Yodit was going to take that or not. There's not right now. So that is one of the things that you would need to consider in your design.
So you'd have to go touch the endpoints to update the firmware.
That is correct. There are some things in the works to maybe allow for that, but currently right now you do need to touch the end nodes to update firmware.
Okay. So I think this may be a question for everybody in turn. But the question is, you guys are making it sound like LoRa requires no configuration for deployment. Is that really true? And we'll start with Patrick.
Did you say me?
Yeah.
The answer is that is not true. You have to, the configuration and provisioning is very, very important. And there's a fairly high touch at this point for how to manage that. The burning EUI information onto the firmware, flashing the firmware, testing that node, making sure it joins, making sure there's no packet drops, or if there are, why. All of that is very important. I think that what we're beginning to kind of figure out is that in order for something to be easily deployed in 5 minutes, you actually have to have a configuration and provisioning framework that enables that to happen. And as I mentioned, we're discussing some things with some foundations, beginning to kind of pull together a consortium for what is an open standard for that configuration. But it's going to be a big challenge. Time to scale requires high touch at this point. We're considering often creating a kit set that might be able to have a bin file that you could download, that you could swap out kits, and then have some signal to the dot that enables those kits to be swapped either through downlink or through BLE or NFC. I think that could work. And we're in conversation with manufacturing partners. One reason we partner with Arrow and others is to enable that kind of new stuff to be inbound on our radar. So the answer is no.
Okay. And Yodit, what's been your experience at OpenSensors?
This takes me to the next slide very kind of smoothly. So it does need configuration, and so the answer is it depends on the most important thing is actually where the configuration happens. If you can make any sensor turn up on site so that non-technical users or engineers can install and deploy it, that is the most ideal scenario. So the way we kind of approach these projects is you kind of get 5 working. get them working, get it working with the gateway, and then you do a pilot of 40 to 50, and then you do your deployment. What we have, what we're releasing, especially for the upcoming deployments, is what we've realized is people care about, there's a subset of people that care about the data from the sensors, but there's a large subset of people that are actually managing these sensor networks. And so let's call them the engineers. So these, if you think about these people, they're not going to jump on a kind of a gateway and do any kind of any kind of configuration. It needs to just work. And Patrick and Herelab actually refer to this as kind of network in a box. So we give these guys, they scan the sensors, we give them an engineering view, does it work, does it not work, and it's just to enable them to install it very easily. They get a operational dashboard that just monitors the heartbeats and the battery status, and it should be that easy. I think for IoT, if all of this stuff is going to work, the 99% are not going to do any configuration. And I think collectively, as an ecosystem or kind of as an industry, we need to make it much, much easier.
We had a question on the placement and site survey. If you had multiple gateways, can you triangulate the location of a node?
Currently, with the hardware that's shipping, you cannot. SKMtech has come out with what they call LoRaWAN V2. There are some pilots going on in that right now. So that essentially next year, but today, no.
Okay. Next slide.
Yes, please.
And we're on to the full questions. One thing I think that Yodit, I know you're using, we don't show as an end node here, is that you're using handheld devices as part of that site survey. Is that correct for the end nodes? These nodes can move around, right?
Yes, these are the MultiTech handheld nodes. So the recommendation always is do a site survey for a couple of hours, like 2-3 weeks before the sensors arrive on site. Make sure your assumptions about the site are correct in terms of if it's in building, what a lot of people do is take the CAD plans of the building, walk around, are the meeting rooms where you expect it to be, kind of is the layout what you expect, and that saves you a huge amount of time and money before the teams, kind of the installation teams arrive with thousands of sensors ready to go. So basically, set up the gateway, do the handheld site assessments, check everything, at least a couple of weeks beforehand.
Mike, we had a question on the V2 protocol you mentioned. Is that going to be sub 1 gigahertz?
Yes, it's still sub gigahertz, but it basically has to do with geolocation. So what you need to do is you need to have a node needs to be in contact with at least 3, if not 4 gateways, and then it will do that triangulation. So it's an addition or an enhancement to LoRaWAN that we're shipping today and that is readily available in the market today.
So I think this is a general question. The question is, since device addresses will need to be unique to a given network and thus provided by the network operator, then is the assumption that all end nodes must be configurable by the end users, or all sensors reflashable?
I think you got to break it into 2 pieces, the sensor and then the node. I mean, the sensor is part of the node. So in the case of the MultiTech dots, yes, they are reflashable and configurable because they have their own onboard processor. If you're talking about just the SKMtech chip and non-MultiTech products, then the answer is not necessarily.
Does the handheld device also give you a GPS location?
Yes, that is what we call our M.dot box. That's the MultiTech M.dot box, and that's got built-in GPS in it, and that's how you do the site survey. So if you do want to get a plot on a map, Google Maps or something like that, you do have to have a view of the sky and get a GPS signal. Otherwise, it's not going to give you, if you're in a building, you probably won't get GPS coverage, but you'll be able to get your signal strength and spreading factor and all the other LoRaWAN details, just not necessarily a firm GPS location.
A follow-up on the V2 location accuracy is, what's the rough resolution on that? Is that 300 meters? Is that shorter than 300 meters?
I've heard 100 meters so far, but the jury's still out on that.
Okay. We got a question on the Semtech picocell as an alternate gateway, which is a lower cost, smaller network trade-off. Is MultiTech working on anything in that area?
Yes, that's based on the Semtech SX1308, and we are doing a low-cost access point. They're kind of scaled down from the full-blown versions of the gateways that we're shipping today. They're 4-channel, less capacity, all-inclusive, internal antenna, more like a Wi-Fi access point, so they're good for inside buildings and things like that. We'll be making the first shipments into Europe actually this month, and North America, we plan Q1 or Q2 for some rollouts. So yeah, we're working on that, but we don't have anything in production on that platform yet.
So the question is, Yodit, could you provide a rough breakdown when you look at the total network cost between the labor and the equipment?
That is the trickiest question. Like all things, I guess it depends. But there is a variable. So the gateway costs, I think Mike might correct me on this, but the gateway itself is around $450, I think.
Yes.
And then the sensors themselves vary between kind of $50 upwards, depending on what they do or what they sense. The labor costs, we're trying to get to people basically. I mean, my aim for the new kind of engineering views and ones that our customers are holding us to is installation should take 30 seconds to 1 minute, and that labor is actually the biggest task. Minimizing that has to be the focus, especially over the next quarter for us.
Yeah, I think to add a little bit here, if you're working from a concept to a proof of concept, from an idea to proof of concept, you're probably working on a premise that you can either do it yourself or you have small scale. The cost of that stuff is pretty high, either in time or in money. We use a contract manufacturer whose value proposition is to turn stuff around in a number of days, assemble it, ship it, have it back in within a week. That's pretty high cost, and that's not including sensors. You can get just the boards from them for $150 built out and ready to go. That's not including the dot and the sensor. For larger scale applications, you can drive that cost down significantly. You can get below 60, 50, and in some cases we've quoted out products for below $30 competing with Wi-Fi. So you can actually do that work if you're focused at scale. And so that to get to scale, you actually do have to solve the configuration and provisioning challenges, and we're hard at work on some POCs that would address that. So you combine the cost of the nodes with the cost of provisioning. is one thing, but then you also have to understand what the cost of management is. And if you're separating the cost out from a normal IT environment, which is either through cellular, you can actually rapidly deploy stuff and not tie it directly into your local Wi-Fi, so that you can separate that cost out. Again, it's the number of units, both in the cost of production, the cost of deployment, and cost of management.
I'm sorry, I got a lot of questions. There's another question on the triangulation location. What's that? How's that going to? Any estimates on how well that will perform in urban environments with reflection?
I don't have any good feel for that. It's definitely going to mean you're going to need to have lots more gateways, because it is LoRaWAN. And you've got to have, the node is going to have at least 3 gateways, if not 4 gateways. So yes, that's going to be a significant factor, and you're going to have to account for that.
Got a question on the MultiTech conduit, the MT CDTs. He says, we bought several of them, which as far as I can tell, only have a command line interface. Is there a web GUI available? Can I upgrade to that? I don't know if it's a question about the dashboard that OpenSensors provides versus what MultiTech is doing.
I think that's a MultiTech question. The MultiTech conduits are available in different flavors. They're open Linux platforms. One is what we call our MLinux. That's just straight Linux. You've got to put your own application on it. The other platform is what we call our AEP, Application Enablement Platform. That's got IBM Node-RED built on it, and that's got a GUI on it. You can update or switch them around. The hardware is the same. It's just the load. So if you have some gateways that it sounds like they were purchased as MLinux, you probably want to update those to AEP. You can go onto our website. We have a tech support portal. You can open a ticket, and our technicians will walk you through that. You can also go to multitech.net, which is our developer site, and there's lots of forums and recipes for doing that.
Cool. Well, I think it's time for the panelists to give us their key takeaways. We'll start with Patrick.
Sure. I think from our perspective, if you're trying to develop, if you're a developer or a design build studio, focusing on partnerships is really important. We couldn't do what we're doing without OpenSensors and MultiTech. Focusing on processes so that you can execute, scale beyond DIY, or just rely on 1 or 2 people. It really does help. And the defining people and working relative to people's needs. All of those things will speed adoption if you're user conscious and focused, and scale. And in order for IoT to work, partnerships, processes, and people are the 3 key parts for us. So, Mike?
Sure. As Patrick mentioned, the partnerships. So basically, when you want to get into this, you have to decide, do I want to get into developing LoRaWAN, or do I want to focus on my or your specific application? With the work that OpenSensors and Herelab is doing with the MultiTech hardware, it easily and quickly allows you to jump in and focus on your application rather than starting at the beginning. One thing that I haven't touched on that's very significant is you've also got to deal with approvals. In Europe, you've got CE, these are radio devices, you've got emissions, safety, and basic CE requirements. In the US, you've got FCC. So if you're not fully prepared to take on all those undertakings, and you don't have RF designers and things like that, you definitely want to work with these products that are off the shelf and focus on your solution, which is going to get you to market quickly, without delays and without surprises, and on budget. Yodit?
Yes, I mean, I agree with Patrick and Mike. I think kind of accelerating deployments is really the focus. I think for, for OpenSensors and for myself personally, the approach I take is always has been the data side. How do we make the data meaningful, understandable? And the what I've noticed especially for IoT is it's always kind of a number of variables that make things quite interesting. So going back to the buildings is actually like, what does utilization mean? What affects it? In kind of taking noise, temperature, and multiple variables, do you start getting insight? And I suppose if I had one advice, it would be get to a stage where you kind of get small wins quite quickly. So do your very quick, 5 sensors in a lab, get it working, see data, see outputs, play around with the data, and just kind of move where you get the wins. Because developing hardware, everything else, it just makes don't wait 2 years to see outputs.
Well, I think we're going to break it here. There is more information available on the different websites. If you've signed up for the webinar, you'll get a copy of the link to where this recording and the slides will be posted. I want to thank the panelists for taking part.
Thank you, Sean.
Thank you, everybody.
Thanks, everybody, for showing up and listening to us.
And a recording of this will be available, so I'll email it to all the participants, and I really appreciate everyone asking questions and getting stuck in. So I can't wait to see what you do.
Okay, thanks everybody. Bye-bye.